it can be quite easy to forget, can be quite easily confused. So let's use today's class as a kind of a recap to summarize everything we have learned. So we're well equipped. Moving on. Let's go. So acids and bases recap, like a revision. So remember we spoke about the pH scale, okay? And as you can see, that acids have a pH of 1 to 6, okay? pH of 1 to 6. So 1 is going to be a very strong acid, 6 would be a very weak acid. pH 7 is neutral, and only water has a pH of 7, okay? But otherwise, acids are pH 1 to 6. Now remember, acids have hydrogen ions, okay? So that is the property, the acidic property of a substance, okay? Hydrogen ion, which is H+. So if we look at something like a weak acid, I don't know, maybe like orange juice, maybe it has a few hydrogen ions, okay? Just like 2. And that would be like pH 6. But if we were to look at a strong acid with pH 1, maybe something like hydrochloric acid, it's going to have more hydrogen ions, okay? So that's the main difference in the acids. Strong acids have more hydrogen ions. Weak acids have less hydrogen ions, okay? So if we move on to bases, bases have a pH of between 8 and 14, okay? 8 and 14. And the molecule, well, it's not really a molecule, the ion that gives bases their properties is the hydroxide ion, okay? Hydroxide ion, which is an oxygen atom and a hydrogen atom bonded together, and it has a negative charge, okay? And it's kind of the same thing as the acids. If you have a weak base, which is a pH of 8, maybe it has only 2 hydroxide ions, okay? And then if you have a strong base, like sodium hydroxide, pH 14, it's going to have many hydroxide ions. Obviously, I've done 2 here and 5 here, but that's just to make it easy for you to see. The difference will be like hundreds of thousands, maybe millions of these ions, okay? But something with a pH of 8 will have less hydroxide ions, and a strong base with pH 14 will have many more hydroxide ions, okay? So the next part is dissociation. If you put an acid or a base, especially strong acids and strong bases in water, they will dissociate, which means they kind of break apart into their constituent parts. So one example is hydrochloric acid, very, very strong acid. If you put that in water, it's going to separate into its constituent ions, which is a hydrogen ion and a chloride ion, okay? Same with a base. If you have a strong base like sodium hydroxide, you put that in water, it's going to separate into a sodium ion and a hydroxide ion, okay? Our final part that I want to recap today is neutralization, okay? Neutralization. So neutralization is when you mix an acid and a base and it makes water and salts. Do you remember before the vacations when we were talking about this, we were talking about the telenovela, the soap opera. So acid is a married couple, base is a married couple, but maybe they no longer love each other and they hook up with the other couple's partner, okay? As you can see here. So with neutralization, you have the hydrogen ion of the acid and the hydroxide ion of the base. They hook up and form water. And then the other half of each couple, the sodium ion of sodium hydroxide and the chloride ion of hydrochloric acid, they hook up and make our salts. This is sodium chloride. Okay, so the pairs of couples, they interchange. Okay, and I hope you can see that with the colors. So these are the questions I'd like you to do today. You can do it in your notebook, in a Google Docs, take a screenshot of this. It's completely up to you. Questions are: what pH are acids? What pH are bases? What pH is water? What ion do all acids have? What ion do all bases have? And then question 6, I want you to dissociate nitric acid into its constituent parts. There are 2. And then finally, question 7, this is a neutralization reaction. I want you to write out the 2 products. Okay? Like I said, this is just a recap today of what we were doing before the vacations. So good luck. I'll be here for the rest of the class. Let me know if you have any questions, and I'll see you next week in chemistry. Bye.